Hello everyone, and once again I welcome all of you to the course on manufacturing methods. So in the previous lectures we have already discussed about various types of casting processes, their advantages, disadvantages, what are their specific speciality, etc. So under that, all those expandable molding process as well as the permanent type of molding process, under special molding process like all those investment casting, like injection molding, centrifugal casting, true centrifugal casting, etc. All those things we have discussed. So now today in this lecture we are going to discuss about the casting quality. So now once we already know about all those type of casting and all, we know how they process the material, how we obtain the final product, how we take out and all. Okay, so now after that, the final step before releasing the product to the market is something like, so we have to be specific about the quality of it. We must have the quality checking, and we must maintain that particular quality, and we can say like ultimately the acceptance or rejection of the part that is being manufactured. Okay, that we have to check, and for that we have to know about the casting quality. So now this casting quality, generally it is in terms of some defects, whether those defects are present or not. Okay, based on that we discuss about the casting quality. So these defects, with respect to which we discussed the casting quality, they are then commonly called as the casting defect. So these casting defects are certain defects which may be there in the final cast product, and because of which the product cast part we might have to either reject it or maybe some additional modification or additional secondary processing we might have to do. So those kind of defects which are prevailing in the cast part are known as the casting defects. So now because of this particular casting defect, that means we are encountering loss, because we have to, if we have to reject a particular part after it has been manufactured, we have like consumed the raw material also, we have considered, we have taken time also, everything is now gone. So this is kind of loss, and that means the importance of this casting quality, cast quality is very important, and that means we must know about the and we must know about the casting defects, and we should be able to detect if any that kind of defects is there, and we must know about the root cause of it, and what are the common defects which may be there and how to avoid them. Okay, so now for getting a particular part which is defect free, that means a perfect part, so for that the whole process right from the very beginning, okay, right from the concept melting of the metal itself, okay, and from there we have to take proper care, and the whole process should be designed properly, and controlling of it should be done properly, so that a sound casting which is free from any kind of defect we can obtain it. Okay, so right from the very beginning in the initial stage, like melting of the molten metal itself, there also we have to consider so that there is no oxidation on the molten metal, etc. We have to handle it carefully, the fluidity of the molten metal, all those things we have to check and ascertain properly. Okay, so now what are the most common casting defects? So the different casting defects which are very common can be classified like this. So there may be some casting defects which may be common to all kind of or any kind of casting processes, like Misrun, cold shot, shrinkage cavity, hot tearing, microporosity, etc. These are the defects which are common to all kind of casting processes, and there are certain defects which are only specific to sand casting process only. Why we are discussing these differences, or you can say the defects with respect to sand casting most like as a separate category, because see, in normal consideration, this sand casting is one of the very versatile type of casting process and one of the easiest method. So in most of the cases where we don't want that, we are not going for that very high quality and all, maybe sand casting itself can do our job, and it is one of the old process, oldest process also, and it is one of the most versatile. So there are certain defects which are only related to sand casting process and specific to sand casting, because we already know in case of sand casting, mold is made of sand. Okay, so that all those binding and proper binding of the sand, okay, maybe all those kind of thing, like it plays important role. And now we get some like defects in case of which are specific to sand casting, like sand blow, pinhole, some sand was, scab, penetration, core sieve, mold sieve, etc., or sometimes even cracking of the mold that we make. Okay, so now first we will be discussing the common casting defects. Okay, so which are common to any kind of casting. Okay, so by this, which are word is common to any casting process, we don't mean that we don't mean that it all those kind of defects will be there on the casting process, but we mean that this kind of defects it may be there in case of sand casting also, or in case of other types of casting also. So now first type of casting defect which is common to any casting we are going to discuss is about Misrun. Okay, so first one is Misrun. So now when this particular Misrun occurs, so now Misruns are cast like in case of Misrun, that means okay, so it is something like whenever it's a defect. And what kind of defect it is? See, sometimes what may happen, a casting it may solidify before even completely filling the whole mold cavity. Some portion which is farthest to the entry zone, it may remain unfilled. Okay, and prior to that even the whole molten metal it may solidify, and some portion may remain white. Okay, so this particular defect it's known as the Misrun. Okay, and what are the typical causes of this Misrun? Sometimes what may happen, the fluidity of the molten metal with which we are working it may be insufficient. That means it cannot go to all the nooks and corners of this particular whatever is the mold cavity we have. And sometimes what may happen, the pouring temperature it may be too low. Okay, so because of that, once again the fluidity might be hampered. Okay, and because of that also, sometimes before even reaching the farthest position or the nook and corners of the I can say like your that particular mold, okay, it may solidify. Similarly, sometimes what may happen, your the rate of pouring is very slow. It means pouring of the molten metal we are doing it very slowly, and by the time we are done with the pouring and all, some portion before reaching even the farthest positions it had solidified. So sometimes once again the reason may be the cross-sectional area of that particular zone on the mold cavity it may be very thin, which hampers the proper entering of that particular molten metal there. So in this particular figure, first figure, you can see this particular Misrun. Okay, that's the problem. So what basically has happened, so from here we have suppose poured the molten metal, it have from this sprue and all. Okay, so this gate it is filling up the mold cavity. Our intention is that it should have gone and reached up to the this, it has filled up this portion also, but before filling up the final portion it has solidified here. Okay, and this particular portion is left blank. Okay, so this kind of problem is known as the Misrun. So next type of problem that we are going to discuss is about cold shut. Okay, so now what may happen, sometimes depending on the design of it, whatever bit of mold, okay, there it may so happen that the two streams of molten metal, there may be two streams of molten metal, and they may approach each other from both the direction. Okay, one maybe it is approaching from this direction, another it is filling up suppose maybe from this direction. Okay, and in that particular case, these two, our intention is that these two streams of molten metal which is coming, okay, and they are going to meet somewhere here. Okay, and now our intention is that they should fuse properly and give rise to a homogeneous particular type of, you can say whatever be the cast product we wanted that. But what may happen sometimes, due to certain problem, okay, so they may not fuse properly, okay, resulting in discontinuity, and this particular discontinuity is known as the cold chart. Okay, from this second diagram you can see this cross mark is the cold chart that we are seeing. So now in this particular case we are pouring the molten metal here, it is filling up the mold cavity like this. Okay, maybe up to this much they have filled up. After that, from this side one stream of molten metal is coming, from this side another stream is filling up that particular cavity, and we wanted that when they reach here they should fuse properly, and actually we should get a homogeneous mixture, but it is not happening, and because of that at this particular portion, okay, there may be some discontinuity, they are unable to fuse together. Okay, so this kind of problem is known as the cold chart. Similarly, we may have one problem known as the cold shot. Okay, and what is this? And this cold shot, it may result from splattering during the pouring process, and because of this particular splattering, what may happen? It forms cause the formation of it causes the formation of some solute globules of metal, and because of this particular thing they gets entrapped in the casting itself. Okay, and how can we avoid this? Pouring procedures and getting system design which can avoid splattering. Okay, we should use that kind of pouring system so that it doesn't make more chaos and all. Okay, and so that there is no splattering of that particular molten metal. So here we can see, due to splashing or splattering, some solid globules of this kind of molten metal has been entrapped here. They have solidified there itself, but in the globular form. Okay, and this particular defect is known as the cold shot. Similarly, we can have shrinkage cavity. Now, what is the shrinkage cavity? It's a depression on the surface or an internal void in the casting. What is maybe the reason? It is generally caused by solidification shrinkage that restricts the amount of molten metal which is available in the last region for freezing. Okay, and generally it occurs on the or near to the top surface of the casting. Okay, and in this particular case, this problem is referred to as pipe. Okay, and what may happen? You can see, so due to some solidification, okay, the shrinkage, that particular problem may be there. Okay, and on the top surface generally we obtain this kind of problem. Okay, and because of the look of it, generally it is known as the pipe formation. So it's a problem, it is shrinkage problem. Okay, and how can we avoid that? By using a proper riser. Okay, riser design should be very proper so that it can accommodate for proper shrinkage. During the shrinkage, solidification shrinkage, the riser should be able to give the required amount of material, okay, molten metal, so that this problem doesn't arise. Similarly, we may have microporosity. And what is this microporosity? It's a network of small voids which are distributed throughout the casting, and mainly it is caused by localized solidification shrinkage of the final molten metal in the dendritic structure. Okay, we already know, and in case of alloys we have that particular uh, dendritic structure. Okay, and in that particular dendritic structure, sometimes in their lateral branches and all, we already know how they grow and all. Okay, so we may have this kind of porosity, microporosity. Okay, so it may be in the dendritic structure throughout that particular, you can say, okay, throughout that particular mode. Okay, we may have some this kind of porosity. Okay, because in the branches of the dendritic structure it may be there, and here in this particular figure it shows various porosity, microporosity, and this micro, as the name itself is micro, so definitely it is in micron level. So here the figures are exaggerated. Similarly, we have another problem which is known as the hot tearing. Also, it is known as hot cracking. It occurs when the casting is restrained, that is, it is not allowed restraint from contraction by an unyielding mold during the final stage of solidification or during the early stage of cooling just after the solidification. And it is basically, this defect is manifested as a separation of the metal, or you can say the tearing or cracking, which is at a point of high tensile stress. It is caused by metals inability to shrink naturally. Okay, in case of sand casting and other expandable mold cases, it can be prevented by compounding the mold to be collapsible. That means easily collapsible, it should be easily collapsible and all. Okay, and in case of permanent mold casting, mold processes, hot tearing, it can be reduced by removing the part from the mold immediately after the solidification, so that we can allow for any kind of contraction. Okay, it should not, basic problem is it has restrained from contraction by an unyielding mold. Okay, and we should allow for the contraction, that means. Okay, so in this particular figure it shows at the highly tensile zones. Okay, we can have some, later on it will develop some crack when once again it gets, you can say, like highly tensile portion and all. So this is also is a problem. And if later stage it develop traps, tears or cracks, ultimately the product is going to fail. So these are some of the defects which are common to any kind of casting process. So next we'll be discussing about some casting defects which are only related to sand casting only, or sand casting only. Okay, so most of the things it is related to the nature of the sand, actually how the sand is being binded and all. Okay, what is the strength of that particular binding. Okay, whether what is the amount of moisture present on the green sand with which we are using the you can say your particular mold. Okay, so these words you already know. So green sand, in case of green sand, basically moisture content is there, so these things you already know. So now we are going to discuss the different problems which may be there in case of our sand casting only. So first casting defect in case of sand casting only is sand blow. So it's a kind of defect which is consisting of a balloon shaped gas cavity which is caused by the release of mold gases during pouring. So what basically happens if we are talking about pouring of molten metal which are very hot, okay, and on the sand mold, okay, which is made of mold, generally green sand we use, that means some moisture etc it is there. And now once the molten high temperature molten metal is poured, okay, so because of that some gas may release in the mold, okay, mold gases. And it ultimately, if the sufficient venting etc air venting it is not there, so generally at the surface, casting surface, or just below the casting surface, there may be a balloon shaped gas cavity, so it may remain. So this is basically known as the sand blow. So lower permeability venting, if it is venting is not proper, okay, so then this particular mold gas it remains here, and as it generally at the top face, okay, so then it will be a problem. Okay, it's a defect which will be there. So we should have proper venting, okay, so that it all those mold gas it vents out properly. Okay, so it should be taken care of. Similarly, the low permeability or high moisture content, if it is there in the mold, then also this kind of problem may be there. Okay, if the moisture content on the sand mold is very high, then the gas release, mold gas release will be kind of higher. Okay, and it may refer to this kind of problem. So next problem is pinhole. And this particular pinhole defect, it also is caused by the release of gases during the pouring. And in this particular case, basically it consists of many small gas cavities from at or just at the slightly below the surface of the casting. Okay, so here also small this kind of holes may have gas release from different portions, so they may also the traces may remain there. Okay, so that may be the problem. Okay, similarly sometimes what may happen, sandwash is a problem. Okay, and what is sandwash? Basically it's an irregularity in the surface of the casting which is resulting from the erosion of the sand mold during the pouring of the molten metal. And because of that particular erosion of this particular sand mold, okay, basically what happens, the whatever the way it has eroded, that particular shape will be there on the final part. Yes or no? So in this particular figure you can see, so suppose it should have been like this, but this portion, this lower portion from the sand mold, it has eroded, and now because of that that kind of void it is present on this particular mold. Okay, which the molten metal will not be able to distinguish whether it is a required hole or required cavity or not required. Ultimately it is going to just fill up that cavity also, and once it solidifies, that particular shape will be there, which is one problem. Similarly, we can have scab. Scab is another problem. It's what is this? It's a rough area on the surface of the casting. Generally, it is caused by portion of the mold surface which is flaking off during the solidification, and it is becoming embedded in the casting surface. Okay, so some portion which has flaked off during the solidification process, and now it has solidified there on the surface, and it has now become a portion of that particular cast part, which actually is not intended. So that scab is another kind of problem. Okay, similarly we may have penetration. we may have mole shift or core shift as the problem and mole crack. So what is this penetration? So basically it's a surface defect, okay, which occurs when the fluidity of the liquid metal is very high, and because of that high fluidity it penetrates into the sand mold or the sand core, okay. And very easily we can say in this particular figure, suppose our intention is to get a class like this, but suppose this is the portion from the mold, okay, and the fluidity of the molten metal is very high, and this side it is, while filling up, it is filling up like this, and some due to the fluidity of the molten metal, it has some of the molten metal has penetrated inside that particular sand, okay. So it is penetrating like this, and this way it has solidified also. So after once it solidifies, what kind of shape we are going to get? We are going to get this kind of shape here, okay. That means it has penetrated inside the can say mold or core, okay, because of the high fluidity. So it's a problem. Similarly, we can have the uh, core shift as well as the mold shift, okay, as the problem. So what is mold shift? It's particular defect which is caused by the sideways displacement of the mold core relative to the mold cope with relative to the drag, okay, and it results in a step in the cast product at the parting line, okay. So sometimes due to this kind of lateral shift in this particular parting line, this is the parting line which is parting both the halves. Upper half is the cope, lower half is the track, okay, and we actually it should be like this, it should have been like this, but one half it has moved or displaced relative to the other. So and it has misaligned the thing, and if that is happening due to cause of this, at the final stage final product also will look like somewhat like this. Similarly, we have core shift, in which case, see, this is the black part, or is the core, okay. Suppose we wanted that the core should be here, okay, but in this particular problem, the just like in the case of mold shift, the core shifts, but that means it is the core displacement, okay. And generally displacement in most of the cases it partially displaces due to the buoyancy of the molten metal, okay. The molten metal, it is kind of fluid only, okay. So here also the buoyant force will be there, and this core is something like in the, while filling up the mold cavity. So the core is something like a, just like a particular part which is under the influence of buoyant force, okay. And that particular buoyant force which is working on the core, if the core is not stable enough, then it can shift that particular core, okay, generally in the upward direction. Similarly, we can have mold crack as one of the problem, and when basically the mold strength of the mold is not sufficient, then there may be a particular crack which is developing on that particular mold, okay. And because of that particular crack which is present on this particular mold site, so the liquid metal will get inside that particular crack, and after that, once it has solidified enough, just like in the case of our penetration, okay, we will get some this kind of shape, okay. But in case of penetration, due to the high fluidity, anywhere it may flow, okay. And but in case of mold crack problem, basically wherever the coal mold is having crack, in that particular direction, that particular liquid metal will flow there, and it will give some shape which was not intended. So these are some of the problems which are, or you can say casting defect, which are only responsible, or which are only there in case of sand casting. So like in the next here, uh, these are kind of the sand casting as well as normal casting, any kind of casting problem. So now how can we go for the or what are the different ways by which the inspection is carried out in foundry process? So there may be different ways, okay. So we may go for visual inspection, and that means in case of just by looking by your eyes, we can detect various defects which may be like these common defects which can be very easily detected by human eye just by visual inspection, is kind of misrun, cold shut, and some surface flaws which are very severe on the surface. So just by looking the surface and all, we can very easily see. Similarly, we have to measure that particular cast part dimensions, or the final dimension of the cast part, so as to check or ensure all the requirement of the tolerance and all. So this is how also foundry inspection is being done, okay, after the final part has been made. Okay, similarly, metallurgical, chemical, physical, and other tests which are concerned with the inherent quality of the cast metal. Okay, so those things are also being done. For this, we can go for various non-destructive testing, and this inspection we can do. Okay, so if I generally go for non-destructive testing, because if we go for destructive testing, then there is no, like, the part we have already destructed, we have broken down, so there will not be any useful now. So that's why generally we go for non-destructive testing. Okay, so like this destructive testing for boundary inspection, that is the cast part inspection, it also includes some pressure testing. So this pressure testing, it is generally used in case of part which are generally made by, like, final part, that means which will be generally used in the high pressure applications like the pressure vessel and all. So we look at any kind of leak that is there in the casting by pressure testing. So in that particular cast part, just like in the case of pressure vessel, some can be high compressed, like uh, water, we can say, at high pressure we can like fill up the particular cast part like this. Okay, the pressure vessel, and you can see if there is any leakage, etc., if it is there. Okay, similarly we can have all those radiographic like ways of detecting any kind of problem, like x-rays we can use, gamma rays we can use for any kind of surface problem, or you can say subsurface problem, detection of any kind of subsurface problem in case of surface, or subsurface problem in case of casting. Okay, similarly we can have magnetic particle inspection. Generally it is used for ferromagnetic material, and we can also go for different fluorescent dye penetration test. Those are like some dyes or fluorescent dyes. Okay, which can, what we can do, we can paint the part with this. Okay, and generally for non-magnetic casting and all. Okay, and we can see if it has gone through the, you can say, like, if it is like sometimes some light and everything, dyes are also there. Okay, it can reflect the, it can give the inspection, that means if some unintended, or if the dye has penetrated inside it, then we can know that means some problem is there. Similarly, we can have ultrasonic or supersonic testing. It is to detect either surface or internal cracks in the casting, and similarly to check whether the particular cast part, it meets all the mechanical properties of strength, etc., or not. We can go for different mechanical testings so as to determine the properties like tensile strength, hardness, etc. Okay, in most of the cases, when we may encounter generally some problems. Okay, but if the problem is not that much severe, then it's often possible to save the casting by doing some welding, maybe some grinding here and there, or some other salvage methods, to which you can say, suppose the customer has agreed, suppose if your customer has agreed that, suppose you show that it's a kind of very minimal defect is there, which maybe just by small grinding, maybe some here and there, and maybe you can nullify it. So if the customer is okay with it, maybe we can go for it. Okay, then we can save the cost. Okay, otherwise if there is it is very faulty, then there is a problem. Okay, so similarly in this particular case, different summary of casting processes, which is advantage, limitations, I have discussed, like for sand casting, cell mold, different pasta molding, ceramic molding, investment casting, etc., etc. What are the advantage, limitation, those things, as I in a single slide has been discussed. Okay, so this basically, these are some of the references that has been used while preparing the slides, and with this I complete this particular module here, and thank you.